Hello everyone. Today we are going to implement remove first method in our doubly linked list implementation. The format is same. First we will do the pair programming or coding, and then after we will come back and we will execute the edge cases on the whiteboard to understand properly how things are working under the hood.
One remove first. So now in this method we have two options. One, we can return null if there is no, like, it's empty list, or we can throw the exception just like we saw in the form of in add method. So in this case what I'm thinking, I will not throw the exception. Instead I will return null if value is not there. Now how many edge cases we need to take care? So I think first is always list is empty. Then, because we are taking care of two pointers, head and tail, it means it's very important we take care of when we have a one value. List has one node, because in that case we need to update also to tail, otherwise we have a memory leak. And then list have multiple values or multiple nodes. In this case, mm, it's pretty easy. Okay, so first we want to implement, that will be very straightforward. I'll say, okay, if is empty, return null. So this case there is no need to we will test later, but for now we are 100% sure if the list is empty we will return null directly. Okay, in case of this, first I will go with the brute force and then we will change or refactor our code. So in this case I'm sure I can check by using this. If size is equal to 1, or I can say if head is equal to tail, it means we have only one value. So I will go with size is equal to 1. In that case, what we really want, uh, it's pretty easy. I want to do head is null, tail is null. And because when we have only one node, its previous and next nodes are already null, so it's pretty easy. And we need to do size minus minus, that one is pretty important, otherwise we will have a bug. And there we need to take care of value which we want to return from this. So in this case I'm saying if head you are not null, please return this value to the our client. So until now it looks okay. Then the else case. So in this else case, what we want to fix, like I have, for example, 1 2 3 4. Okay, so this is our list and my head is at 1. What I want first, I want, okay, head, you should move to the next node. So in this case what I'm saying, okay, head you are 1, and now move towards 2. Good. Then head, your previous node should be null. Okay, so in this case once I move towards head dot next node is, now this one is head. I want to release the first node, otherwise there will be a memory leak. I'm saying, okay, your previous node should be equal to null and size minus minus. So I think until now everything looks good, except there is a one memory leak which I can see, but I will show you in our first testing. So first case is list one dot remove first dot, so also print list one. So this is our first edge case. Then we are going to make second edge case. In this case what we are saying, list 2 dot add one value at any point, okay, 1. Then we will show this list, then we will remove this, and then after that we will show again, and we will see what is the result. And then the third case is we have multiple values. In that case I can add multiple values 1 2 3 4. So basically our list is 4 3 2 1, and I'm saying show this. Then I'm saying okay, remove first, and then again show. and then we will see what are the results. So first scenario, when we are showing this list is empty, then I try to remove first, so it's returning null and then null. Looks good. Then after the second case, I added a one value. Now we have this list. Then I say remove first, list to show, then remove first. We did remove first, which is returning us a one value, and then after a list looks nice. Then the third case is list 3 4 3 2 1. Then I removed first, so 4 is removed. Now we have 3 2 1. So everything looks okay. Until now it looks everything is working perfectly. There is no memory leak, but there is one memory leak, and we can fix that. uh, or before that we can I want to refactor this code, and then after that, so can we improve or refactor this code? So this condition we need to call, like if you see this condition is like here, uh, head is not, so in case of a first, for example, we have only one, so once we have a one node which means once head dot next node is always null, so head will automatically make sure it's null, automatically it will be null. So this one is done. Then I need to take care of this tail because that is not going to do anything there. Then this previous node will also, if head is null, previous node null, nothing will happen. Nice. This one is improved. Then if size is equal to 1, we need to do tail null. That one check we need to do, or I can do this, and I can say at this point if you are empty, it means you need to do tail null. We can run again, and if results are same, we can go towards the next. So yep, still working, but only we did some refactoring. Now what is the memory leak? I will show you that later also in a whiteboard if you don't understand at this point. So basically what we are saying, uh, like I will show you how I can show. Yeah, so for example, I'm taking this temp as a head, only temporary, so I want to show you something, and at this point I will show you. Okay, so currently okay, maybe I will try to run only this one example, no need to run these. So we have 1 2 3 4, and we will remove first, and then I will show you the memory leak. So in this case, the memory leak which I got, so first we are saying okay, head is 4, then next node until we have 1. So 1 2 3 4, our head is 840 and our tail is 843 address, and we are expecting 840 head should move towards the 842. Okay, so in this case, only to show you, I have a new variable temp to show you memory leak, because in our current implementation gc can't uh, release that node which we deleted. How we will see? Okay, so I also have this temp is saying, temp is currently kind of a whole linked list, doubly linked list. Okay, then next I'm saying okay, head, you should move towards the next node, your next node. In this case now head might change, so now you can see head is going to start from 3, and then next node, next node, but had still have this previous node. You can see pn equal to 4, which makes sense, and I did this null. Okay, now head is started from 3 to 1. It looks good, everything looks good, and our tail is still there. But what is a memory leak? So if you can see, in case of a temp, I still have this issue, that value, the temp which is assigned to head, we can access from the next node. So what I'm saying, okay, this previous node is null, so yeah, there is no more previous node, but still I have a one check, like I can show you like this. Okay, so temp is my first node which is already deleted from the head, but that still is there. So like temp dot next node, it's 3, previous node I can't access, but there is this temp.next node, the link is still there, which is kind of a memory leak, because once gc will try to take this value, gc will say okay, anyone is referring to this, and yes, code will say yes, my current existing linked list is referring to this, but we don't have an access to that. And if I want to fix this, what I can do, I can simply say okay, once head you are moved, to go back to your previous node, and then your next node do null. So if you still don't understand, it's okay, we will do this example on a whiteboard, but I will run again and then we will see what will happen. So in this case, again come to the temp. Now I took head to the next node, so it means now head is 3, temp is still 4, but in this case, once I say okay, head previous node dot next node null, in this case what will happen, now you can see temp is only an independent object. Before that, temp is still have the access of the whole linked list, but we don't have an access. And after this point, we are good to go. So it means we fix that memory leak. So I can remove this. Okay. Now we can discuss the time and space complexity. So basically, it's a big O of one operation. In every case, it's a big O of one operation which is independent. We don't care how many nodes you have. Especially, there is a special one case which is empty, otherwise it's always a big O of one operation. And from the perspective of a space, we are taking a one temporary variable which we can ignore from the big O analysis, and it's like same, there is no impact.
Welcome back. So we already saw all the edge cases. So client can call remove first when there is a list is empty, when there is only one value, when there are multiple values. So we can execute one by one all. So edge cases are empty, empty list, one node, and multiple nodes. So we need to take care of this. So once we have an empty, it means I have size which is 0, I have head, and I have tail, and both are currently null. So in this case, once the client will call list.removeFirst, we will return null. And you remember in our code we wrote if is empty, return null. So that is the case, which is pretty easy. Okay, now we can move to the next case. So we have only one value in our list. So in this case, head and tail both are referring to the same node, and the next and previous is already null. So in this case, we have two implementation. Like we implemented in a two ways. First, a brute force approach. In brute force approach, what we did, we have a size is equal to 1, and we are saying okay, if it's 1, do head and tail equal to null, and size 1 should be moved to the. But now we will execute from the last code, the final code which we wrote. In that code, what we did after returning the null, we are saying okay, we will have a value which will be head dot value. So in this case, my value will be 1. Then I will return this. Then after that, what we did, we are saying okay, head, you should move towards the next. So we did like this, head dot next. So in this case, I'm saying okay, do this and go move towards the next, which is null. So now it's null. Then after that, what we did, we are saying okay, head dot previous dot next. Like you remember, we fixed the memory leak. Instead, we will discuss this line in a next edge case, in a next use case, that will be better. So in this case, next null, then we did h dot head dot previous node equal to null. So in that case, basically it's already null, there is no previous, so nothing will happen. Then we have a size minus minus, size will move towards 0. Then we have a check if is empty, tail should be null, tail should be null. and after that we return 1. In that case there is no memory leak, so now we can move towards the multiple nodes example. So code is still here, so I will write only that new node. Okay, so now in this case we can make multiple nodes. So I have 1, 2 and 3. So head is currently is 1, tail is currently is 3, size is 3, heads is this. So this is our list. In this case we need to understand also memory leak. Maybe I can make this more clean so we can understand easily what we are doing. And this is the last node. This one is head, this one is tail, and now we start our multiple node edge case. So first we are making value. So head dot value which is 1, so I'm getting okay you have 1. After that what we did, we are saying okay head, you need to move head dot next node. So that is our code. So in this case what we did, we moved head from here to this. Okay, I'm still writing the code in which we have a memory leak, so we can really understand. Then after that we did okay head dot previous node equal to null. So head dot previous node null, there is no more. And then we did size minus minus, which moved to do this 2, because it's not is empty, we are not going to do tail is equal to null, and then we return the value. Now in this case you can easily see there is a memory leak, because this link is still exist. So in this case you remember I created a only temp variable temporary to show you this. So in this case what will happen, when GC will come from our code, we don't have access to this because we don't have any reference to this, but this link is still there. So once GC will come, GC will try to ask okay I'm going to remove this object from a memory, anyone is referring to this or this. So it will say oh I am referring to this. Okay, then GC will come somehow at this point and GC will ask can I remove this, and head is still there, so we have code. So to fix this what we did, we basically you can see head move to the next node. Then I want to say okay, and before that we have this. So I'm saying okay head dot previous node dot next node. So at this point we added a new line which is saying head dot previous node dot next node is equal to null. So we run first this head move to here, then I'm saying okay head go towards your previous node, from there you have a next node, please make this as null. So once I did this, there is no more connection, and after that head dot previous I'm saying okay is null. At this point there will be no more memory leak, and now once GC will access this, GC will check anyone is referring to this or this one is referring, and say no, so GC will collect this and we have there is no more memory leak. And from the time and space complexity there is no complex yeah, everything is pretty easy. We already discussed, so there is no need to spend some time on that. I hope today we learned something new. See you in the next video. Bye.